Actually, online Etch-a-Sketch things that I used to try to use until I finally just broke down and bought one because they're not as good as the real deal. Okay. There. Oh, make this go away. So, what we did last time is we talked about a whole different way to construct, to represent a function, and also through that representation you get more control over the finished product. You can do things you couldn't do otherwise. And so there's a lot of art, design, engineering that uses parametrically defined functions because then you can control different aspects more directly. Okay. So we went through how to graph them. Oh, I'm real life lagging. That's crazy. I think we finished this whole thing. Remind me, did we finish this whole thing? I'm pretty sure we did. Yeah, because I remember talking about eliminating the parameter down here. We made a diagonal ellipse, which is difficult to do with pure X and Y graphing. What's up? Oh, good. I was wondering what you're showing you. Okay. Yours is more pink than mine was. Okay. So obviously, now that you feel semi-comfortable with just the idea, we're going to do calculus with this. Okay. So just to kind of like get us there. There. Normally we're given y is a function of x, and then we can do dy dx, and everything's fantastic. Yes? Now we're going to be given, there's a couple things wrong with this approach for the way we're given a function now when we're dealing with parametrically defined functions. Because now we're given a function defined in pieces. Doesn't matter, Jeff. We'll call this, f of t, g of t. I think we're going to use that same designation later anyway. So now the question becomes, how do I determine? So real quick, I wish I still had, because I couldn't find the paper. Didn't this come out to be roughly, let me see if I can do this really roughly. Came out to be roughly something like this, yes? I mean, really roughly. You guys would, holy shit, that should connect to the y-axis, but but all I need is a quick, do you all agree with me that the slope here is 0? And the slope here is infinite, and the slope here, now this is where things get interesting. The slope here, yeah, that gets interesting. But it's definitely not 0. It's just a question about, since we're traveling this direction, does that change what the slope officially is? We'll find out. Are you guys kind of with me? So if I can graph something, I inherently must be able to talk about its slope. And then the question becomes, can I just guess at the damn thing, or is there an actual way to calculate it? And of course there's a way to calculate it, right? So if I want to get dy dx from this mess here, yes? Thankfully, this is too good to believe. What can I really get directly from the x and the y as defined parametrically? What can I get directly? Let me see if I can ask this question in a different way. What if I had, let me give us a concrete example. What if I had x of t is 3 sine t, y of t is 4t cubed minus t? What calculus could I just do directly to something there? Be more specific. Yeah, d by dt. So it would be easy as shit for me to get dy dt here, yes? So this is example, Jeff. So what's dy dt? Yeah, your brain sometimes doesn't trust it. You're like, nope, can't be that. It's too easy. And what's dx dt?
3 cosine.
Yep, 3 cosine t. It's crazy. Now, what do you hope you can do to get dy dx? Because, real quick, I just want to make sure you understand. On the graph, does t show up? Shit, no. T is behind the scenes creating the x piece and the y piece. Yes, and that's why we get so much more control. Normally, the x piece creates the y piece, and we lose some control, or we didn't even know we had more control, possibly. Now we do. But on the graph, the slope I see should only be related to y and x, because those are the only things I can see. So there's an inherent interest in eliminating the dt piece. Okay. Now we're still going to have a t dependence, because every point is t dependent. So thankfully, how do you think I take what we've just discovered and create dy dx? Yeah, if I take this guy's derivative divided by this guy's derivative, and this is why I'm firmly in, always forget which, I think it's Newton's camp. I think Newton was the one that was cool with infinitesimals, and other people disagreed that they existed. This is a beautiful example here. What's the algebra say? What happens here algebraically? Just the stupid what's do what? The dt's cancel, right? Which is good. So what I want to do, so in this case, this is kind of silly. Dy dx would just be, in this case, 12t squared minus 1 over 3 cosine t. Okay. So let me do this. Let me try. God, I can't believe I don't know what I did with the paper we worked on yesterday. But let me try to recreate this a little bit. This was there. I think this was here. I know this was here. I don't remember. Down here, exactly. It went down here, yes? To here?
Yes.
And I think here it was 4 negative 3.5?
Yeah.
It's funny, this shit I remember sometimes. And then this was here, same way. And then this was here, I think, yes. So then it went and I know we had another point here, I think, to get better resolution, but who cares? So if I want to get this, I have to know what value of t causes that. So can everybody take a minute and figure out dy dx in this case? I want everybody to take a minute, figure out what is dy dx for that first parametrically defined function. So just do it in parts and then throw them together. You got it? So let's see. dy dt is easy as shit. It's just t. That's almost too good to believe. And then this isn't too terrible. We got to remember the dreaded chain rule comes into play. So we get 4 cosine of stuff times, pi over 2, so I'm going to make it 2 pi. Is that cool? Mm-hmm. And then I could even make this t over 2 pi cosine pi t over 2. Okay. So everybody with me? If you still have your sheet from the other day, which value of t, and if you look carefully, there's more than one, which value of t got us to this point? The point 0.04. If you look at your table of values from what we did last time. I think I just said yesterday, but you guys know what I mean. -4. What else got us there? +4. Okay. So if I plug a -4 in for t or a +4 in for t, they both represent this position, yes? And of course, now this should be, let's see, where am I at? Yeah, what do I get when I put a 4 in here? So I'll get -4 up top, and I'll get 2 pi. What is, if I put a negative, I'm sorry, am I doing -4? Yes. If I put a -4 in here, I get -2 pi cosine, and -2 pi is 1. So I get -4 over 2 pi, which is not what I expected, which is troubling me. But I'll be all right. Did I forget something? Let me think. Let me consider this. All right, so then the slope here is not actually 0. That's interesting. Oh, of course it's not. I'm being so stupid right now. So you get to all revel in my silliness. I'm pretty sure I showed you guys that this picture keeps going. Thank you. I'm doing exactly this. Not exactly this problem, but this idea in my other class. And we had one that was contained because they were both based on sine and cosine. But this continues. Okay. So since we put a -4 in, that's when this started. And sure enough, that would have been coming down. So that was negative this. And if I put a +4 in, it's going up through that point, and it's symmetric, so it's going to have the positive of that. Okay. The world just shifted back into place. Where should it have a 0 slope? No question about it. Maybe some question, but if you think about it, since it's symmetric, it almost has to be 0 here, yes? Because on one side, it's going down to it, and the other side is coming up from it, so it's pretty much got to be 0 here, yes? And what t value gave us an output of 0, -4? 0. So if I put a 0 in for t, sure enough, I get 0 over 4 pi. I'm sorry, 0 over 2 pi, so that becomes 0. Kick-ass, okay. And if I put the t that goes here, I'm going to get what?
1 over 0.
I'm going to get infinity. I'm going to get undefined. Yes? Okay. You guys kind of with me? It's really, for parametric, it's almost too good to believe. You look at the parametrically defined equation, you're like, please, Jeff, let me just take the derivative with respect to t. Please let that be a thing. And it is. There you go. So it's just derivatives. And then you put them over each other. Here's the one caveat. If you want a specific place on the graph, you must know the t value there, because everything's dependent on t. Let me stop for a minute. Okay. You can potentially solve for t and plug it in here and make this dependent on y or x or both. But very often that gets a little worse. After taking derivatives, the relationships are not as direct, let's just say. So how's everybody feeling so far? You guys okay with this? Yes?
So you got the -2 over 11 by plugging in 4?
That's a pi, sorry. Yeah, we plugged in -4, that was here. And sure enough, at -4, we were actually coming down through this point. So it makes sense it was negative. Okay. So calculus, at least derivatives, for parametrically defined functions is way nicer than you might have thought. Yeah.
So, are you getting the rate of change of both y and x? When you take that ratio of their derivatives?
Well, I mean, the top is the rate of change of y with respect to t, and the bottom is the rate of change of x with respect to t. And since t is changing at the same rate for both, that should make it make more sense as to why I can just eliminate it. Whatever's causing y to change as t changes is in proportion to what's causing x to change as t changes. And that's why this kind of makes sense that it should be this simple to do. I'm hoping. Okay. Plus, just algebraically, there's numbers. It's what we would do. Right? But you're right, there's always a deeper level you can go. Why does it even make sense in the first place to be able to do that? 11. Okay, maybe. So it's that straightforward. In order to do a problem like this, I have to give you x and y as functions of t, and if I want the derivative, you just take the derivative of each separately. And at this point, you are all very aware that derivatives are always easier than integration. And the amount of integration we've done in this class, almost any derivative questions, like, thank the gods. I'm hoping. Okay. Okay. So there's not much more really to say about that. So can you guys turn this over and try the first 3 out? You can work with other people near you if you want to.
Yeah, because I sold them. Made money. You ever see them? Well, I also account. And then here's one of my babies from last year. And then I don't know what happened. Nothing big. It's scary. Not the other day. This is pecan.
All right, guys, I'm going to start to catch up to you.
This is cherry.
Oh, shit. There.
I don't know what this one's was.
Let's see if I can do this.
This is forest.
There we go.
Oh, and then oh, that's toothless. I did that, but this is just oh no, period. This is chopper.
Woo! I got your attention. Plus, I was celebrating. Look what I did. I got the same answer you guys got, I think. Most of you that I looked at. Number 2 had some of us a little bit tripped out, but you get your dyax first. That's your first thing. Because tangent, horizontal, vertical is slope discussions, so I need the slope function. So just to cut to the chase, dy dt is, what is it, Jeff? T squared minus 1. Dx dt is 4t. Now, so I'm going to say something that I'm always wondering if I should. Don't just take dx dt and set it equal to 0 and say that's where it's going to be vertical. Because dy dt could, like if y was natural log of t, it's 1 over t. It contributes to causing it to be vertical. So some of you guys might not even thought of that, but it does on the surface make sense. What's on the bottom of dy dx? dx. So let me set that equal to 0 and find the, no. Set up dy dx, simplify it, then take the bottom of that. How do I find the vertical asymptote, vertical slope locations? Yeah, so to get the vertical, I would take 4t equal to 0, so t is 0. That's crazy. To get the horizontal, t squared, the only way a fraction can be 0 is if the top is 0, and then I get plus or minus 1. Now I said find the points. So if I said to somebody, where is Sam? And you say 3 hours and 2 minutes, and I'm like, one of us is having an issue right now, right? So I think I told you guys this, that t, we call it t because very often you can look at it as a time. Mm-hmm. So if you tell me t is 0, I'm like, great, where is it? Not when is it, right? Okay, it's almost like a Doctor Who issue. When am I right now? So when is this? Where is this? The when is 0. What's the where? 1 0, because you just plug a 0 in. Woohoo! And then this one is 2. So if t is 1, I'll get 3 comma negative 2/3. And if t is negative 1, I'll get 3 comma negative 4/3. Crazy sauce. Now, real quick. just because. Has everybody got all that written down? Okay, so I want to go to Desmos, which means I'm going to have to log in, which means I'm going to have to put my little story that I created in for my password. Okay. Yes, ma'am. Go ahead, sorry. Oh. Wait a minute, let me do that again. So if I plug in a -1, it'll be -1/3 -1.
It's minus t. It's minus t.
Oh, it is minus t. So that should be minus -1.
Yeah.
So plus 1, and then that would be 2/3. Yes, okay. Thank you. I sort of crowdsourced it and kind of glanced at it, and it made sense. So please, dear God, don't take what I write down as anything approximating gospel. I don't know. This year?
Yeah.
That was me just doing it real quick.
Oh.
Just plug a -1 in, and the thing I wasn't careful about was this. Yeah. Okay. Okay, now, if I graph this, do you guys know how to graph parametric equations in Desmos? And you're like, I just learned about them last time I saw you. You all can see that. I can't. What's going on? Hello? Hello? Why are you? Give me a second. Okay, that's fine. Okay, now become... Yes, thank you. It wasn't up here. Okay. Here's how to put this into Desmos. Parametric. The way you put parametrically defined functions into Desmos is you make it a point. You make a point, and in the x place, you're going to put the x definition, which in this case was 2t squared plus 1. And then y, blah, 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 blah. 1/3 t cubed. Don't go there. T cubed, what was it? Minus t. Is that right? Yes. Kabam! And then you have to tell it. And in this problem, I didn't say where, so I'm going to say -10 to 10. Let's see if that gives me enough. Okay, so can you guys see somewhere where it is vertical? The slope would be vertical. Looks to be right there, right? Which looks to be the point 1, 0. Is that what we get? Oh my God. Okay. Sorry. And then can you see locations where it looks to be horizontal slope? Like right here roughly, yes? And right here roughly. So if I had to guess, I would say that that's 3, and that's 1 1/3 maybe. And this is, if I go down, that's 1 1/3 down. So that's positive 2/3 negative. Is that right? 1 1/3?
It's going by halves.
Oh, and this one is going by halves also. Okay, I gotta pay more attention. So that's 1/2. So it's a little more than a half, which relates to 2/3, 0.66666, and then negative 0.6666. Okay, thank you. That by itself is kind of cool. I like that little graph. That's a little fish whose tail got crazy. Oh no. Okay. But I need you to see how we have a whole different way to construct points and then plot them. So on one level, everything we've ever done with a graph should still work. I should still be able to find a tangent line, blah, 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 blah. Because I can see the graph. I can see what the slope looks like. I can see there should be a tangent line here, for example, right? Now that tangent line can't be immediately dependent on t, because it's literally constructed from elements of x and y from the graph, yes? So somebody had a really good question related to that. Let's try that next problem out. So I want the tangent line. So of course the first step. What two things do I need to get the equation of a tangent line? Slope and a point. Cool. The point's easy. What's the point? Plug a 0 in. 2 times 1. Plug a 0 in. Sign don't like it there. And now, of course, to get the slope, you got to do the derivative, right? And that's not that bad. Not as bad as you might have thought. So this would be cosine t over, what is that, Jeff? T plus 2 e to the t plus e to the t, which is t plus 3 e to the t, if I want to shove all that shit together. So how do I get the slope at the point that I'm curious about? Plug in 0 for t, and then I get what? Yeah, I got 1 over 3. Okay, so I saw that on a lot of people's papers that I saw. I didn't really look at a lot of people's papers now that I said that. And now it's the same old shit as before. Y minus the y piece equals 1/3 times x minus the x piece. So I get 1/3 x minus 3, blah, blah, blah. Okay. So if I did plot that, and then I plotted 1/3 x minus 2/3 on top of that, it would do exactly like you saw back in 180. Same stuff. So on one level, you should be very happy that introducing this parameter t does not make the calculus in terms of derivatives that much harder. Barely more difficult to do. Yes? And again, it should make sense because the graph is still an xy graph. And everything you did in calculus was very visual, and then you figured out the math that you had to do. You could see the slope was becoming whatever, blah, blah, blah. You could see it. Same thing with these kind of graphs. Then we talk about area. So, area is not going to be as bad as it seems like it. Oh, before I get too far, I do want to do one more thing with this. Of course I do. You know me, you've met me before. So let me write down what we got. We got this. Jeff, that's what we got. Now, of course, in Calc 1, what did you guys do after you studied the hell out of dy dx? Second derivative, yes? And then, of course, you did like n derivatives, and then we got here, we do infinite derivatives. Why not, right? I want to know what the second derivative is for this, because concavity should still be a thing. Because again, I can see it. Does it look like it's concave up, concave down? I should still be able to do it using some calculus. What's the symbol for second derivative? Not y double prime.
D squared.
Yes.
1 dx squared.
And the reason that is because if I have a y sitting there just minding his own business, and then I come up on the y, it's out there in the forest, I see a little y, and I come up to him, and then I do this to him. Ha ha. Okay. So that becomes dy dx. And then he's just sitting there now, he's like, what the shit just happened? And then I come up to him again, and I attack him with another dy dx. That's doing twice derivative with respect to x. So of course this is d squared y over dx squared. Now to be honest, we should put that like that, but we're fine. We know what we mean. Is everybody with me? Now how does that help, dear God, Jeff? How does it help anybody? This is what helps us right here, believe it or not. So if I have this, what is our dy dx actually a function of now? No. With the problems we're doing, parametrically defined functions, what is dy dx a function of? T. Yes? If you look back at everything you did in number 1, number 2, they were all functions of t. Of course they were. Therefore, in order to successfully do this second derivative, I need to take a derivative with respect to t again, yes? And what we do is exactly what we did in the first damn place. So all I did, what's the only thing I did? That's still here. The d is still here. The dx is still there. What's the only thing I did? Is everybody with me? The d is still there. The dx is still there. The dy dx is still there. What's the only thing I did? What's the only new thing in there? Come on, just tell me. You don't have to tell me anything else. What's new? dt is new, yes? Why is it allowed to be there? Because what am I allowed to do to any fraction in the universe? Multiply or divide by the same thing. Yes, on the top. So I divided top and bottom by dt. Why am I allowed to do that? Because dt is accepted to never be zero. It's an infinitesimal. It's the smallest positive number if you want to make some math people cringe, and I tell them, calm the shit down. Okay. Whoever you take in Calc 3, try to say that to them and see how they react. Is dt the smallest positive number? No, just to see how they feel. So for the problem we're looking at, right here, I'm just going to shove 1 over 2t plus 3. And then on the bottom, I'm going to shove, what was it, 2t plus 3? Because that was dx dt, yes? The great thing is you've already done this. You just have to put it in there. Bless you. Are you guys with me? A little bit? Can you guys do that? Go ahead, do it. I need you to notice how even there's more I wrote, we did the exact same thing we did for the first group. We just introduced an over dt, and it took care of all the problems. Why did we do it? Because we could. We're allowed to. And it made the problems go away. I think you get negative 2 over 2t plus 3 squared. Because this should be, it would be negative 1 over 2t plus 3 squared times the derivative of the inside. So it would be negative 2 over 2t plus 3 squared times another 2t plus 3 is 2t plus 3 cubed. I believe that's what you get. And then you can plug numbers in and see if it's concave up, see if it's concave down. I don't think I assigned too many second derivative problems because it depends on what you're doing and how much you're going to do this. Okay. So I definitely wanted to do at least one example of a second derivative, and it's nowhere near as bad as it might seem at first. Okay. So let's go back in time. Let's say I'm given f of x, and it goes from a to b. Or I slice it off from a to b. And I want to know the area underneath that. This would just be, you're not going to believe this. It would just be that. So the fantastic thing is, and this is going back to where I gave you this earlier. Now we say, what if this was actually defined parametrically? So what do I need to do here? How do I incorporate this? I literally put what there? G of t. Because that's what y is, yes? I'm going to come back to the limits in a minute. What do I need here? Now here's where we can get a little creative, a little side work. And this is the same thing we've done This is going to be an integral using functions of t. That's where we're going, yes? So what do I want at the end? dt. So I can rewrite this like this. It's really dumb the number of times we do this kind of thing. That is how to go from one to the other, is you just sort of do this. Can we get dx dt? In symbols, what would dx dt be? What is x of t? F of t. So what's dx dt? Dx dt, f prime of t. And prime notation is perfect to use as long as you only have one variable. It's understood to be a derivative expected at one variable. Yes. So when you get to calc 3 and you have multivariables, oh holy shit, you're going to see much less prime bullshit. Okay. That's not as bad. Now, what about the limits? Can I still put a and b on there? What were a and b? What did they represent? A and b, what did they represent? They were what x was doing. What was x doing? It was going from a to b. Is that necessarily what t is doing? No. That could be t equal to 38. And that could be t equal to 52. I don't know. So what we do is we just replace a and b with alpha and beta. Ha-ha! I mean, just symbolically. All you got to do is put the right numbers for t. Yes? Same thing as always. When you do u sub, you have to change the limits because the limits were what this variable's doing. You need to know what the new variable's doing. Okay, I like it. Same idea. Do I have an example down there? Blah, 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 blah. There. So try this. I love this problem. Oh my God. I love this problem so much. I don't know how that makes you guys feel, but too bad. It's a little creepy, Jeff. Oh, well, too bad. Yes, that's key. It's enclosed by the x-axis and that curve. I inherently mean kind of like the blob that's in the middle, but let's see if you guys can figure out what to do with that. Coordinate with people near you. If you want to have other people that go, I don't know either, you can sit there and stare at each other. Call me over if you want to stick in the right direction. Just to help you out a little bit. Does anyone have an idea what to do to figure out your limits? I mean, figuring out the inside of the interval is easy as shit. So go ahead and do that first. Figure out the inside, and then I'll help with the limits. Very often the limits are the harder part. What are you guys working on? Start recording here. That would be good. Yes.
I think it's just like 1 plus 3 when A and B. I think you just plug in A into T. Like how you do your substitution.
Plugging A into T?
Yeah.
What is
Because
Zero?
we don't have an A. Like we don't have an A, so literally
It
it will
says-
be an equation.
it? It says the x-axis and the curve.
For 3 ever T.
Oh.
I think it's like that.
Wouldn't it be this one and the one on top?
Why?
Because it says the
Yes.
x-axis and the curve.
No.
Or would it be the whole function? The bottom's gonna be the x one.
I don't know what the fuck is.
Well, this is enclosed by the x-axis, so whatever curve it is, whatever you have.
Yeah. Yeah. So now you just got to worry about the limits. I don't. Oh yeah, I do.
It's from 2 to 1.
I don't know. Let's find out.
Is that a good way to simplify it?
So the only one you have to take a derivative of is x, because you can kind of truncate this to be y x prime dt. Yes. So what is x prime? 3 over t. Kick ass. Macy's being very patient. So what do you do? Okay. So then to set the integral up minus the limits is easy. You shove the y in there, and you shove the x prime in there, and you shove the dt in there. Yay! And of course, I could integrate that easy, and then I'm missing the last step. So how in the world do I get the limits for this? Well, what is the definition of the x-axis? What's the definition of the x-axis?
Y equals 0.
Y equals 0. So how do I determine when this curve hits the x-axis? I set y equal to... Do it. Okay. Question.
Yeah. He wanted to do something.
Yeah. Okay. Oh yeah. Okay. Aw. Two little spiders found each other. That's so nice. Okay. Set equal to 0, divide by negative, divide by 2, factor, yes? Trying to be nice to yourself because everything else is being mean. So somebody's got to be nice to ourselves. So I get t equal to,
2, 1.
yeah, 2 and 1. Cute. Now there's a really good point here that gets a little bit more interesting. Which one do you think comes first? Does it really matter in terms of how it's drawn? I don't want to get too deep into this. But no, you're doing it in order of the key creation, because it's... Let me see. I'm pretty sure. I don't think you have to worry about too much. We'll see if I'm right. I don't remember. Let's find out together. So I'm pretty sure we can put 1 to 2. And then this would become, what's this, 18 minus 12 over t minus, you could do it, Jeff, 6t. Yay! And then this would become 18t minus 12 natural log of t. Don't really need the absolute values, but it's a habit. And then minus 3t squared from 1 to 2. So it'll be 18, gather. It'll be 36 minus 12 ln 2 minus 12 minus 18 plus 12 ln 1, which is 0, plus 3. Good Lord. So what is that? 18, 6, 9. minus 12 ln 2, which tells me maybe it is got to be the other way around. Yeah. Because that's, well, let's see. What is that? No, that's positive. Yeah. Okay, that's fine. Because ln 2 is negative. Yeah, if you plug it in the calculator, can somebody do that for me? What do you get?
0.6822.
Woohoo! Okay. So not very much area. It probably just barely peaks above the x-axis and comes back down. You can graph it in your calculator or Desmos. Okay. Yes?
So what order would we, how would we figure out the order?
Well, no. From what... This is the one thing I didn't even think about looking up earlier, but I'm pretty sure it does. You do it in terms of how t comes, how t creates the function. I don't think there's an issue about turning those around. But just in the moment right now, I'm like, was there something about that? I don't think there is. I think you do it as t comes. Yeah. I have to look deeper into it. I don't think I got that specific in the homework. Yeah. So the interesting thing about this type of derivation is it's really easy to, it's almost too easy of a derivation. And you don't, weirdly, sometimes you might not trust it as much because we didn't have to do that much to suddenly make it able to handle t all of a sudden. But at the same time, it shouldn't be that surprising because to create a parametric system of equations, we just added one level. So then to do the calculus, it makes sense that there should just be one more level of consideration, which is really all we did to make t fit in. I don't know if I'm making any sense to you, but very often students disconnect if the derivation is too easy, which is funny to me. It wasn't hard to get that integral, was it? This idea was very easy. Suspiciously easy. And I think part of our brains goes, no. That might have just happened to me when I thought there was more to it. Okay. Yes?
How do you overcome that?
Overcome.
Thinking, oh, it's too easy. It must be.
Oh, man. If I knew the answer, I'd write a book and make a lot of money. But it's repeated accumulation of evidence, which is funny to me. It's really funny to me. That's how we grow and change as humans, is we just collect evidence. All right, I'm not going to go into I am not certified to discuss psychology, even though it was my first major, and I still kind of keep up with it. But you have to kind of point it out to yourself. When something is simpler, you have to point it out to yourself and say, it's okay that this is this simple, because it's just one extra thing. You have to kind of tell yourself that. Because if you just let it sit, a little piece of your brain is going to be like, what the shit? Wait a minute, no, what? There's got to be worse than this. This is wrong. And then when you're doing a test, you start doing extra shit. Because you think it's supposed to be harder, so let me throw extra shit, and maybe I picked the right extra shit. I've seen this as I grade tests. People make it worse than it was. And like, I thought it was supposed to be harder. And I'm like, don't make it harder. Just do it. Don't add stuff because you're like, I think it's supposed to be harder. Maybe if I add stuff, that's the right extra hard stuff. I don't know if I'm making sense to you, but as a teacher, I've seen students do this. Why did you do this? I thought it was harder. But why did you do this specifically? Because it made it harder or something? I don't know. Okay. Sorry, I'll stop. The psychology of all of us as we learn new shit is fascinating. But who has time? Are you guys semi-decent with this? Semi? And again, you can graph it on Desmos. Make sure that it makes sense. What did we get? Where did I put the answer? Yeah, make sure that it makes sense that it's this small. Just you can graph it and see if the area between the x-axis and the curve is tiny. It should be tiny. Okay. One more thing. I can't remember if I assigned any homework of this, but this is kind of useful to do, especially since this becomes bigger in Calc 3. So it is possible that you guys took somebody for Calc 1 that didn't really talk about this. But if I do this, your brain, of course, is trained to think I'm going to talk about the area underneath that. But no, I want to know what the length of that curve is. And that is a funky-ass question. Do you all agree? If the curve was straight like this, that would be easy. Even if it was straight diagonally, I could do Pythagorean theorem. Look at this thing. How do you what?
What do you want from me?
So, does anyone think they were taught this in Calc 1? I don't think I got that far in my Calc 1, to be honest. I'm not going to talk shit about somebody when I don't think I even made it there. This is surprisingly easy. Surprisingly easy. Let me zoom in. Well, let me just do this on here. Do you all agree with me? The sucky thing about this, like I just said, is that it curves. If it was straight, I don't even care if it's diagonal. We have old Greek dude that helps us out. Yes? If it's straight this way, I don't need old Greek dude. Okay. Or that way. I can figure out all three of those situations. I can get their lengths. This sucks because it curves. But locally, does it curve? And when I say that, I mean on the order of dy and dx. So, instead of like pretending like I'm zooming in, here is dy. If I go from here to here, this is dx, this is dy. That's fascinating, Jeff. So then connecting them is a straight line, yes? Now, the way I've drawn this, it should be delta y and delta x. Technically, because these are gross steps. Not like, ooh, gross, but big steps. But I'm going to pretend like I've zoomed in. The more I zoom in, what should happen to this curve?
It should find
And I'm assuming it's differentiable. It's got to be differentiable across its, between A and B. The more I zoom in, the more linear it should become, which is why flat earthers still exist. Because they go, look, it's flat. I'm like, no, we're just really close to it. No, it's flat. Okay. Okay. How do I get this? And of course, I'm going to call this side ds. And you all should know s is arc length. Yes? How do I get ds?
square root of dx.
So it would be the square root of
Dx squared
dx squared
plus y.
plus dy squared. Yes? So then how do I get the complete length then? I just take this piece and this piece and this piece and this piece. Why am I singing? I don't know. But and I just add all those dumb pieces together, yes? And of course I get the total length if I add up all the sublengths. And why is it perfect? Because my resolution is infinite. Because I put a little d there, which means it's a true infinitesimal. Are you guys at all with me? Remember delta y becomes dy on the order of infinitesimal steps? Okay. So if I want to get the arc length, I would integrate this. Now, do you guys notice an issue right away with this? Oh, the fact that you can't see it is an issue. Yes. There's an issue. There's a major issue right now. Yes. There's no D on the bottom? Is that what you're saying? I think there's, what did you say? There's no... Oh, beautiful. Kick ass. This is the part that makes me a little sad that it's something that you might not even notice. But integrals never make a damn bit of sense if they don't have the D something at the end. And so many of you guys just write integral money stuff at the end, and when Calc 3 comes, it's going to kick your ass if you don't. You've got to pay stupid amounts of attention to what's at the end of your double or triple integrals in Calc 3. Yes? So you should have been paying extra attention to them this entire time. So here's what we do. I'm going to factor a dx out. I'm going to factor a dx squared out, but the square root of dx squared is dx. So I'm going to do this. I did my part. Now, what's left inside if I do that? What do I actually factor out of the inside? Dx squared. And the square root of that's dx. So if I factor dx squared out, what's on the inside? What's left? 1 plus something that looks very familiar. Yes, cool. That is, and this would be a to b. That is from chapter 8. That is just the arc length of some curve from A to B. Now, the funny thing is, that is the direction I would go if I just wanted to talk about non-parametrically defined functions. But I go back a step and then go forward if I want to introduce parametrically defined blah, blah, blah. What do you guys think I'm going to do? What do I need to show up now if I have parametrically defined parts? And more specifically, I want dx dt and dy dt to show up, yes? So then, what do I actually do then? One way to look at this is, I start with this. Why are you writing it again, Jeff? Just do it. You already started. And then I multiply top and bottom by dt. You guys with me? Do you all agree with me that the square root of dt squared is dt? So then if I do that, that goes in and makes dx dt squared plus dy dt squared. And now I got my little dt on the outside, so my integral symbol, and Jeff, don't freak out. And now I'm going from the same way as before, alpha and beta. And there is no definitive general relationship between A and alpha, B and beta, because it just depends on how your functions are defined, what the values of t are that make it go where it's supposed to go. Are you guys all with me? Like what value of x got me here? A. Ooh, it's amazing. What value of t got me here? I don't freaking know. Depends on how you define the damn thing, yes? If my x is t plus a, then t is 0. But it doesn't have to be t plus a. Okay. Maybe. And again, I don't remember if I assigned arc length. Did I?
Yep.
I did. Oh, sweet. Then it's just plug and chug shit, yes? Can you get dx dt? Of course you can. Of course you can. Can you integrate? Of course you can. Okay. And I'm pretty sure I was careful to pick ones, because when you have a giant square root inside of an integral, part of your brain should go, oh shit. Because integrating radicals without functions on the outside of them is troubling, because then sometimes you might have to use trig sub. Did I do that?
No, you did not. They were pretty simple.
Man.
I'm letting you.
Fine. All right. So at least, okay, so they don't get as hard as I wanted them to, which is fine. Okay. I think that's all for 10.2. So the last thing for today, there's a little bit of surface area, but I really don't think I made it there. But that's not very exciting. By the way, no, I'm not going to. Okay. So what I want to do with the rest of the time, and we're going to leave a little early because I just decided I want to. How many of you guys, so we just did parametrically defined functions. And it should have been something that should have come up before for you, but depending on who you took pre-calc with, blah, 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 maybe it didn't. How about polar coordinates and polar equations? How aware are we of that? Okay, so so a few of us aren't sure if you're aware. Okay. So, as I've done before, I can't remember if I've done this. In 281, I do this all the time. But we're all sitting on an XY plane right now. Yes? So if I wanted to get to Christian, I could walk so many up, that would be my Y, and so many over, that'd be my X. So one use of the XY plane is to locate points. So if you're interested in astronomy at all, there's like a curved plane around the surface of the Earth, and there's like right ascension and declination to find stars in the sky. It's kind of like the equivalent of XY motion, yes? And then more about the angle that you have to turn through to get to where that is. You guys are all with me. And the neat thing is, of course, all the elements move because everything's freaking moving. So, okay. Instead of using X and Y as if I was in a neighborhood that's perfectly lined up, right? Go this many houses down, this many houses up. Instead of that, I'm a crow, and I'm on top of somebody's house. They got to go out and go over and go up. I can freaking just go there, yes? So as a crow, if I want to get to Christian, I'm looking at 0 degrees. I can turn by so much of an angle and then fly so far. And I still get to his position. Yes? So one major thing about XY coordinate system is identifying the location of points. But the XY coordinate system is just one of an insane number of ways to locate a position in space. Not even space, because we're just talking about 2D, yes? Calc 3 is where you get to the 3D analog of polar coordinates. So what I'm saying is, if I have a position in space, of course, in rectangular coordinates or Cartesian coordinates, that's just move so much left and right, move so much up and down. Whoop-de-doo. How do I convert that to this new idea? So I want to take our rectangular coordinate system and convert it into polar, which means rotate by a certain angle and then walk out a certain distance. So this is relatively easy. This is like a really base level application of trig. So how do I get R? Yeah, old Greek dude, yes? Good old Greek dude coming in handy. So R squared equals X squared plus Y squared. That's a conversion from rectangular to polar. Yes? How do I get theta then from X and Y? How do I get this angle? And I put it in the first quadrant, but it doesn't matter. I could have put this anywhere, but it'd been the exact same work. So like Ivan said, tangent of theta would be what? Y over X. So then theta is the inverse tangent. Y over X. Very often we write these two things, and I love that we write those because they each require one more step. But we write it just because it's cleaner to write it like that. So if I give you a coordinate in XY system, you can convert it to polar relatively easily. So for example, glasses would be good. What if I give you the point? What you got, Jeff? Oh, I don't know. Here, let's do this. Yeah, negative rad 2, negative rad 2. And I want that to go to r theta. Please do that. Make it happen. X squared plus Y squared and other stuff come from So then this will be negative rad 2, negative rad 2. That's 2 plus 2 is 4. So then r is 2. And then tangent theta is equal to 1, y divided by x, yes? But what, sorry?
None. Keep going.
What quadrant am I in?
You're in quadrant 3.
So you have to be really careful about just looking at the equation you write. You have to be careful about what quadrant you're actually in. So when is tangent equal to 1 in quadrant 3? Yeah, you know it's going to be a 45-degree angle because that's where sine and cosine are equal. And it's got to be 5 pi over 4 to be in the third quadrant. Cool. So I've changed this xy point into an r theta point. Where's it at? There it is. By the way, I have no idea why in history we didn't make this theta r. That would have actually made so much more sense. Because a standard equation would look something like r equals 5 sine theta. What looks like the input? Yeah, that's shit, man. Oh well, but it's a minor annoyance, but it's still something. You know, and I like to find anything and complain as much as I can. Okay. So converting between polar coordinates, well actually so far we know from rectangular to polar. How do I go the other way? The other way is so much easier. If I know r and theta. So everybody got all that, by the way? I don't want to go too far away too quickly. Okay. If I know r and theta, how do I create x and y? This is kind of dumb. Yes! So one thing that isn't really true, but I like to say anyway, is that cosine is the percentage of r that's in the x direction. Sine is the percentage of r that's in the y direction. So cosine theta times r is x. Because that's the percentage of r that is x. And y is r sine theta. That's crazy. As long as theta is in the base. So that's dumb. Yes? I don't know if you guys are with me. Converting from polar back to rectangular is easy. That's all I can say. It just is. So here, let me give you... Actually, wait a minute. Yeah, why not? That's easier to do this if I give this to you. Anytime. What?
More black holes?
Black holes?
This looks like a tunnel. If you just
Oh,
look at
sure.
this mountain.
Yeah, don't jump in. Alright, so guys, the top of this, these two, easy as shit. Yes? Please see me if that's not true, because they should be. This should be like, yes, 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 please, give me a bunch of this shit. Do you guys know your tangents, by the way? Like, if I just said, let me help you out. You ready? Because for the longest time, I didn't have tangent memorized. Do you guys know your sines? And I don't mean Aquarius and stuff. What's the sine of 60 degrees? Yes? What? Yes. Okay, so listen. The way I teach this, number one, if you've ever taken me before, how do I feel about Sophie? Does anyone know?
You said it sucks.
Oh, it sucks so bad. It sucks so bad. And nobody believes me because all I can see is what matters right now to them. And I'm like, that's not going to help you at all later at all. Sine likes y, cosine likes x. So the closer I am to the y-axis, the bigger sine is. The possible outputs between the extremes are 1/2 rad 2 over 2, rad 3 over 2. Which is square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2 is 1, square root of 0 over 2 is 0. So there's the pattern. If I'm close to the y-axis, it's square root of 3 over 2. If I'm closer to the x-axis for sine, it's 1/2. If I'm right in the middle, it's right in the middle, rad 2 over 2, yes? So when somebody asks me, hey Jeff, what's the cosine of pi over 6? I literally don't have that memorized. I don't have it memorized. I don't just say something because I know that this goes to this. I think to myself, okay, pi over 6, closer to the x, cosine likes x, rad 3 over 2, the bigger output. Are you guys with me? Mm-hmm. That's what got me through. If you have a different way to go through, then why didn't you speak up earlier when I asked you? Because it should have worked for you. Okay. Tangent. What is on top of tangent? Totally. Sine. Yes? Tangent, sine over cosine. When sine is big, tangent's big. When sine is small, tangent's small. So tangent of 60 degrees, it's going to be the bigger option. And you just have to know the options for tangent, besides 0 and infinite, is rad 3 over 3, rad 3, or in the middle, 1. Because 45 degrees is where sine and cosine are equal to each other. So tangent of 60, tangent goes like sine loves 60, it's bigger, so it's rad 3. Tangent of 30 degrees, Tangent goes like sine. Sine hates it there. It's far away from its home. Little turtle pulls its head in. That's how I teach with the turtles. So, therefore, it's rad 3 over 3. It's the smaller option. Are you guys at all with me? Not really? Screw you, Jeff? Okay. Because you know, you've met me. You know I'm going to want exact answers. So if you put decimals from your calculator, I ain't going to take it. So for example, this one. I'm going to convert to polar. So for example, that's not too bad. R is easy enough, yes? R squared would be the square root of 3 squared, gather square, plus 4, so R is 2. Yay. Tangent would be what? Tangent theta is 1 over rad 3, which is rad 3 over 3, which is smaller. When is sine small? Pi 6. There you go. And I know I'm in the first quadrant because my point's positive, positive. There it is. Done. Are you guys with me? Okay. So of course, if you're doing the calculator, you're going to get some decimal. I don't want to see that shit. I don't want to see it. We basically did 3b, although that's in the what quadrant? It's 3b. Quadrant 2, so that would be 3 pi over 4, not 5 pi over 4, like we got a minute ago. It's the same stupid number, just in a different quadrant. Okay, how do you guys feel about the points? If you actually try some of them out, and as long as you have a decent trig, and if you don't have a decent trig, how the shit did you make it to here? Because all of chapter 7 was trig. Are you kidding me? All right. You're like, dude, I just barely made it. Okay. This stuff gets more interesting. I love this shit. So tell me this. If I see anywhere in a problem where I have to convert from polar to rectangular coordinates, if I see r sine theta, what can I replace that with immediately? R sine theta, what can I replace it with? Y. If I see r cosine theta, I can replace it with x. And if I see r squared, I can replace it with x squared plus y squared. All right, are you guys kind of with me? What do I almost see here? I'm missing an R, damn it. So can you just put it there and go, Jeff must have just forgot. Let me just put an R there. Because I did not forget. How do I get an R to show up there then?
Multiply both sides by R.
Yeah, just multiply both sides by R. So what's R sine theta? Y. And what's R squared? Anybody know what this is the equation of? Here, this will be the last thing we do. Ever. No, it's for today. It sounded like, oh my God, it sounded like a threat. This will be the last thing you do. Bless you.
Bless you.
Sound like he said Pikachu. Pikachu. So I subtract 5y. I complete the square. Half, no, Jeff. Half of negative 5 is negative 5 halves. Squared is 25 fourths. Add it to both sides. Is anybody with me? Subtract 5y. I need to gather my y's together so I complete the square. Then I get x squared plus y minus 5 halves squared equals 25 fourths. Does anyone know what that is the equation of? Circle. It's a circle. Center what? X squared plus y squared has center 0, 0. This has been shifted how? Five halves up, yes. When the thing is inside with the variable, it does the opposite of what it looks like. You guys remember the transformations? Okay. And then what's the radius? X squared plus y squared equals r squared. So what's the radius? Careful. 5 halves. So if I draw this, believe it or not, I could draw this relatively well. You're like, well, believe it when we see it. So 2.5 is the center. I'm just going to put a little circle there. 0, 2.5. The radius is 2.5. Is 2.5. So it goes out to there and down to there, and it goes out 2.5, and then I get a circle. Whee! So if you graph this stay with me now. In your stupid expensive graphic calculator. Oh God, that's from this morning.
What did you do? Okay.
Wait, if I just change it back to this, it actually becomes what we decided was the symbol for the grand unified front of butterflies. But you don't have to agree with me. It's okay. So if I go back to polar mode, and I put in here r equals, what was it? 5 sine theta. It's kind of nice how our all-purpose variable button just changes based on what mode we're in. If I hit graph, am I in a weird? I might be. There. Look, oh, why does it look like Stewie's head? Because our display is rectangular, so it's always going to smush it in that dimension. Are you guys at all with me? If I made it like, what is it, 16 by 9 scale, then that would become circular. It's because of the rectangular. Okay, that's enough, Jeff. So then you start wondering to yourself, what if I put a 2 here? What would happen? Huh! So any predictions if I put a 3 there? If I put a 2 there, I got I forgot the name of the damn things. 4 leaves, there it is. But if I put a 3 there, I get 3 leaves. What? Anyway, sorry. So then you can just start playing, what if I add cosine of 1/2 theta? Ooh, that starts looking neat. Anyway, sorry. This morning I just started playing with this and I'm like, oh no. But now that you know, you got parametric mode in your graphing calculator, you have polar mode in your graphing calculator. You don't have to be like me. But if you never go in there and just start plugging different numbers in to see what the hell happens, be sure to give yourself, if you do, just in case anybody does, be sure in the window to give yourself a lot of room for it to play. So I would make this maybe 6 pi. Yeah, see? Because when you start changing the period of stuff, which is what I'm doing when I'm changing the inside, I kind of want to give it enough room to fully explore its the cycle, its full cycle. So anyway, that's enough. So next time, obviously, we're going to get into the calculus of polar. Did I announce a quiz yet?
I don't think so, no.
Good. Well, not good. Let's announce a quiz. Oh, you're so excited about this, I know. You had a feeling. It's got to be Thursday, because when is our next test?
Thursday.
So what am I going to have for you this Thursday?
Is it gonna have this black hole?
I'm going to have a quiz,
Then practice.
and I'm going to have it nothing but black holes. No. God. It's going to be, what is it, 10-1 and 10-2. Yes, just 10-1 and 10-2. Just parametric. Yes. Very, 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 very basic calculus, yes, because I know we just went over that today, but somehow it doesn't bother me enough to not get it on your next quiz. Okay. I'm also going to have the practice test, because the test 4 is next Thursday. So next Tuesday, Jeff, somewhere there needs to be letters. Next Tuesday is review day. Next Thursday next is test 4. Holy shit! And then I think next Thursday I'll also have the practice final. Maybe I'll give it out earlier. I could just put it out there right now and be honest, I've got it. Is everybody with me what's happening? Yes? Yeah, sure. So the next time it's hacked, nobody can get it. If you remind me, if somebody reminds me, I can throw it up on Canvas. Yeah. Okay. Yeah.
Is there any way of taking the quiz today?
Why? What's up?
I'm not gonna be here and she's not gonna be here.
No. So then the grade you make on the test will count in place of the missing quiz.
Okay.
Yeah.
But it would be a 0. Please.
Okay.
Do it right now.
No. I don't do makeup quizzes. There's just too much to keep track of. I'm sorry. I'm sorry. I can give you a copy of the quiz. some point.
I got a feeling.
What?
Well, my grades in mid-tech. And I want to
I can't guarantee that a black hole won't develop in the middle of a. I'm not going to put it on there, but if one happens to come into existence, I don't know what to do. But I'm not going to put it.
I need this quiz to push in my grade.
Hold on.